In section 9.4, we're going to continue our work on trying to solve quadratic equations. Remember that means that we've got ax squared plus bx plus c equaling 0, and we're trying to figure out what x values have an output or a y value of 0. We already said that graphically what that means is we're in search of the x-intercepts on the graph. And in 9.3 we gave a method that was called, don't write this down in your notes, that was called solving using square roots. And we were able to do that in a situation like this where maybe 2x squared minus 1 equals 49. And we were able to say, well, you know what, we can solve this equation because we can simply add 1 and get 2x squared equals 50. Divide by 2 and get x squared equals 25, and then take the square root and say x is plus or minus 5. And that's what we did in 9.3. But remember I said that the reason we're able to attack this x squared is because there's no x term. There's no b term in there. And so that's why that method works, but the minute you throw in a b term, that method doesn't work anymore. So in section 9.4, we're going to have a method to help us attack how to solve ax squared plus bx, and we're going to have a b term introduced here, plus c equals 0 by factoring. So we're actually going to take a skill you already hopefully remember and know how to do, which is factoring, and apply it to help us find the zeros of the equation, or the x-intercepts of the graph, or to solve this for x. Alright, so the third method for solving is called to solve by factoring. Well, before we do that, we have to kind of come up with a math rule here. And suppose I were to tell you that. Keep track of this in your head. 2 times 4. Suppose I were to say they evaluate this. So in your head you're thinking 8. And then maybe I say times 2 times negative 5 times pi times 1/7 times 0 times 99. If I were to ask you, what does that equal? And for a while, you were probably able to keep up with me in your head, and then you probably said, she lost me. But the minute I said times 0, what that means is it doesn't matter what came before it or what came after it. The product, or the answer after you multiply, would be 0. Anytime there's a 0 in one part of a multiplication problem, the answer is 0. So if I have that in reverse, if I have an answer to a multiplication problem equaling 0, well then what must be true? That means that either this piece is 0 or this piece is 0, because we can't get a 0 out if one of the pieces of the product is not 0 itself. So that means that either x plus 2 has to equal 0. If it's not, then 2x minus 5 has to equal 0. If neither one is 0, well then my product can't be 0. 0 must be somewhere in there. Then this is called the zero product property, and what that allows us to do is figure out what x is. Because if I were to take this equation and solve it, I would say, well, I need to subtract 2 from both sides, and I get x is equal to negative 2. Or equivalently, negative 2 plus 2 is 0. And what that means is I get a 0 in this first part of the product, and it doesn't matter what comes after it. 0 times anything equals 0. Well, if the first piece isn't 0, then that means the second piece has to be. So we solve that, and we just use our linear algebra to balance the equations here, and I get 2x is equal to 5, and I divide by 2, and I get x is equal to 5 halves. Alright, so what that allows me to do is figure out the answers without graphing and without using square roots. Now notice, these are already factored, which makes it easy. If 2 factors multiply to equal 0, then either the first factor is 0 or the second factor has to equal 0. And we just solve them separately. We subtract 1, we get 4t is equal to negative 1, and then we divide by both sides by 4, and we get t is negative 1/4. If that's not 0, then this has to be 0. And we get t is equal to 2. Either one of these answers will result in a product equal to 0. Watch it being tested just so you trust it. 4 times 2 plus 1 is 9. 2 minus 2 is 0, and the product is 0. So those are the 2 solutions to that equation. So how about 4x times 5x plus 1 equaling 0? Sorry, that wasn't on there, it should be. What are the solutions? Well, I've got two factors that multiply to equal 0. What that means is either 4 times x is equal to 0 or 5x plus 1 is equal to 0. Well, the only way for 4 times a number to equal to 0 is if the number is 0. I mean, use common sense. Or divide by 4. Either way, if x is a 0, I get a 0 out. 4 times 0 is 0, and it doesn't matter what comes after that. Or the second factor can equal 0, which means 5x would have to equal negative 1. I divide by 5, and I get x is equal to negative 1/5. So there are two answers when there were two factors. So let's go down here, and it asks me for the solutions, and luckily for me, they're already factored. So I need to know what would make this equal to 0. What makes this equal to 0? Well, when they're nice and easy like this, you can see that x would equal negative 1, or x would have to equal 5. You don't really need to set those up. That's just too easy. It's just the opposite of what's there. Likewise over here, that one's easy. X would equal 4. 4 minus 4 is 0. Or 2x plus 3 would have to equal 0. We'd subtract 3. We'd divide by 2. And our two answers would be x equals negative 3/2. If I plug that in, I get a 0 out. Or x equals 4. If I plug it in, I get a 0 out. So let's go look at letter C. Which one of these can I do easily? This one, because there's nothing in front of that y. So for y plus 14 to equal 0, obviously y would have to equal negative 14. You don't really have to set that one equal to 0 and solve it. Or 2y plus 1 would have to equal 0. Again, if things multiply to equal 0, one part of them has to be 0. And so when we solve this one, we'd subtract 1, and then we'd divide by 2, and y equals negative half would be my other solution. Let's go do letter D. All right? So neither one of these is easy to do because of this number out front. So I'm going to take each one separately, set them equal to 0, and solve them. For this one, I'd add 2, and then divide by 7. Again, I'm going kind of fast here, but remember I'm on a time limit with these videos, so they move quite a bit faster than your in-class notes, but you can always pause and rewind if you need to. I'm going to get 5n is equal to positive 4. I divide both sides by 5, and I get n is equal to 4/5. And these are my two solutions when I had two factors that multiply to equal 0. And it seems pretty easy, and I could use that theory no matter how many factors I have. So on this one, if I have all of this stuff set equal to 0, I have 1, 2, 3, 4, 5 factors. It means I'm going to have 5 answers. If those 5 things multiply to equal 0, one of them's got to be 0. And again, with numbers, if I have 5 numbers that multiply to equal 0, at least one of them has to be 0. So what we do is we take each one on their own and set them equal to 0. Well, this one doesn't require any work. For x minus 4 to equal 0, x is 4. For x plus 3 to equal 0, x is negative 3. And for x to equal 0, x would be equal to 0. So here's 3 of the solutions to those 3 easy factors. The other 2, I set 9x minus 8 equal to 0, this piece, and I solve by using my linear algebra skills, and 8 divide by 9. 8/9 is another solution, and my last solution will come from setting 3x plus 7 equaling 0. And again, it's addition, so I subtract. Multiplication, so I divide. And I get x is equal to negative 7/3. So I had 5 factors with 1, 2, 3, 4, 5 solutions. Now keep in mind, we're working with quadratics, and those generally always factor into 2 factors, so we won't be having that many, but the theory behind it's the same. So what do we do now? Remember, our goal is to solve 0 equals ax squared plus bx plus c. It generally is not going to already be factored for you. So in order for us to solve it by factoring, what we do is we get one side equal to 0, and then we factor the other side. So let's go do it. You should already know how to factor. All right, let's go take a look. Is this equal to 0? Yes. I'm going to factor this quadratic. So here's chapter 8 coming at you, where we say it's unfoiling. We'd have to lead an x and x. We have to end in 5 and 3, or 15 and 1. 5 and 3 being our obvious selection. Both have to be positive because of a sign analysis. And I've now factored it. This and this are equivalent. The only thing is this factored version allows me to get my solutions. Because if those things multiplied equal 0, either this is 0, which means x would have to be negative 5, or this is 0, which means x would have to equal negative 3. So those are my two solutions to the quadratic equation. Now furthermore, had I graphed this one, what I know is, first of all, I know it opens up because it leads in a 1. I know that it hits at negative 5 and negative 3. So it's going to come like that, roughly. All right, those are the x-intercepts, or the values that have a 0 out for y. So let's move right along here. We have to get it equal to 0 and factor it. So we have to lead in m's to get that m squared. We're going to end in a 7 and a 2. We have to add up to negative 5, so I have a minus 7 and a plus 2. What that means is my two solutions are 7 makes this one 0 if I plug it in. Negative 2 makes that one 0 if I plug it in. So those are my two solutions to the quadratic equation. Letter B. All right, and the factoring should come back to you quickly. We did it in chapter 8. So again, I'm going to have to lead in P and P, end in 5 and 4, or 2 and 10, or 20 and 1, but we've done that one enough where you should recognize that this is your winning pair. One of them has to be negative, and the larger number gets the sign of the middle. So minus 4 and a plus 5. That is factored. It asks for the solution, so make sure you don't quit when it's just factored. You got to keep going. So I'd get p is equal to 4. That would make this factor 0. Or p could equal negative 5. And that would make the other factor equal to 0. So what do we do when we have the number out front? Well, we remember in chapter 8 that what this means is I can lead in a 2a and a 1a. I can end in 2 and 9, 3 and 6, 18 and 1. And I have to find that winning combination that'll give me the 15. So let's take a look at this here. I'm seeing, and I'm going to do it quickly for you because again I'm on a time limit. I only have a couple minutes left. I've got 12 and I've got 3. And as long as both are negative, I'll be able to unfoil this into 2a and 1a. Here's my 2a squared. I am going to end it in the 3 and the 6, making sure that the 2 goes with the 6. 3 in the middle. I need two negatives. And it's now factored. The question isn't done though. It says what are the solutions? For that to equal 0, either this factor is equals 0 or this one does. This one's easy. A would have to equal 6. There's one of my answers. This one, we set it equal to 0. I'm going to do it down here. Then we solve it. We add 3 and we divide by 2. And my two solutions would be 6 and 3 halves. So on the next one it says, today's method for doing this one, we're going to factor it. And this is a weird one. It's that easiest kind if you spot it. Remember for that to factor, it's called a difference of squares. So we lead in the same because 4x squared is 2x times 2x. We end in the same, 4 times 4 is 16, and we do 1 plus and 1 minus. That's one way to factor it. And then I would say, well, that means x is equal to negative 2 or 2. Or I could pull a 4 out first and call it x squared minus 4, because these both have a 4 in common. And I could say that's 4 times x minus 2 times x plus 2. Well, again, in order for that to equal 0, x would have to equal 2 or negative 2. Same answers. That's today's method. Factoring and then solving by setting each factor equal to 0. But because this is missing a b term, I can actually solve that using the 9-3 method. There is no b term. I can plan a direct attack on x. I add 16 to both sides. I divide by 4, and I take the square root. The danger is you have to remember the plus or minus, or you're going to miss one of the solutions. When you do it by factoring, you never miss one of the solutions because it physically breaks into two factors. So, why can't you do A, B, and C? These up here, two ways, and the answer is because there's a B term. And that's the end for today.